All right, let's take a look at multiple springs. So what happens when we have multiple springs attached, whether they're in series or whether they're in parallel? So I have a couple demos set up right here just to kind of show us what that looks like. And when we do multiple springs, typically the thing we need to think about is we need to think about what is the equivalent spring constant of that group of springs, and how do we find that? So the first thing we need to understand is what's the same and what things add up in our scenario. So in a parallel situation, gravity's pulling down, but both springs are pulling up. Meaning when I think about the forces acting here, the total upward force from my springs is going to be the sum of those forces. Okay, so what that means for me is the forces add up. Meaning the total force or the equivalent force of those springs is going to be the sum of all of the forces. Now, if you have more than one force, you can imagine just adding however many springs you have up. Now, when I hang this on there, I'll note that these two springs are going to stretch the same distance. Now, if they have remarkably different spring constants, that this thing would maybe get tilted a little bit, they wouldn't. But for the most part, if my apparatus is set so that it causes them to stretch the same and it doesn't tilt, we're going to say they stretch the same. So they have the same stretch. Again, my goal here is I want to know what things are the same and what things add. So that means that whatever their stretch distance is, it's the same for all of them. Okay. Now, if I go over to the series and I want to know what's the same and what's different, okay, so this spring, if I imagine that spring above it is not there, is supporting all of this weight. Or if I think about this spring is supporting all of the weight below it. And because we're dealing with ideal springs that are massless, this one is supporting the same amount of weight as this one, because this one has negligible mass. So it's supporting that block just the same as it's supporting this spring and block, because it has negligible mass. So what's the same? They have the same force. Okay. So we have FEQ is the same as F1, which is the same as F2. So what adds up then? Well, if this top spring stretches this much and this bottom string stretches this much, the two combined stretch this far. So what adds is the stretches add. Meaning that the equivalent stretch is going to be the combination of all of the stretches of all of the springs. So again, we want to figure out what's the same and what adds. All right. From this, to figure out our equivalent spring constant, we're always going to start with whatever the adds thing is. And we're going to use our equation for a spring that the force from a spring is equal to Kx. Okay, so let's think about this one here. And what we're going to do is we're going to substitute in what force from a spring means. So it means the equivalent spring constant times the equivalent stretch is equal to force 1, which is K1 times how far spring 1 stretched, plus K2 times how far spring 2 stretched. The benefit here is what's the same? XEQ, X1, X2. And so because those are in all of my terms and they're all the same, we can go ahead and cancel them out. And so we find out that the equivalent spring constant is equal to the sum of all the individual spring constants. So in other words, KEQ is equal to the summation of all the individuals. This is true for springs in parallel. What about series? How is this going to look? Okay, so instead of x, I'm going to have to substitute in, okay, so force divided by k is equal to x, so let's do that. So EQ is going to be force EQ divided by KEQ is equal to force 1 divided by K1 plus force 2 divided by K2. All right. But what's the same? The force is the same. So because FEQ, F1, and F2 are all the same, those are all going to cancel, leaving us with essentially 1 over KEQ equals 1 over K1 plus 1 over K2. This is typically how we'll write this. We can also write this another way if you'd like. We can write this as KEQ is going to be, if I take the inverse of adding their inverses, so I add up the inverses of the spring constants and then inverse that, I will get my result. Okay, so let's go ahead and write this as series. Now, these equations are not given to you on the AP test. However, you do need to be able to kind of figure them out, whether you memorize them or whether you use this idea of what's same and what adds. There you go.